I also just wanted to quickly review going backwards. So if you're given a polymer and are asked what monomer or monomers could it be polymerized from, the first thing I do is look and figure out what's the linkage. And in these examples, these are all polyamides. And then how many linkages are there per repeat unit? So up here, I only have one linkage per repeat unit, and these two are the same thing, just drawn differently. So what I need to do, and the way I tackle these problems, is I slice through the repeat unit. And you got to be mindful of the wraparound. But so if I slice through this, I'm only making one slice. I'm only going to have one monomer. Okay. Here, I'm making only one slice, but it's the wraparound, so it looks like it's two. But I can still see I only end up with one piece. So both of these would be polymerized from some kind of amino acid. And so I know nitrogen needs 3 bonds, so I'm going to add back a hydrogen. And I know carbon needs 4 bonds. And I know that an amino acid can polymerize to make a polyamide or a nylon. I can do the same thing when it is an from an AB type polymerization. If I look at this, I can quickly see I've got one amide here and one on the wraparound. If I slice through the first amide and slice through the second amide, I can now very quickly see this had to have been made from 2 monomers. And if I write those down, I've got NH, the stuff in the middle for the monomer, NH, okay? And then carbonyl, the rest of the monomer, carbonyl. And so I need to add, nitrogen needs 3 bonds, I need to add those hydrogens. Here I could make 2 choices. I could either add chlorines to make it a diacid chloride, or I could add OH groups to make it a dicarboxylic acid. In this case, I'm going to add chlorines. But again, this could have been an OH group as opposed to a chlorine. Both are equally correct. There's no way to know if it was made from a diacid chloride or a diol. Okay, I hope your reviewing for the exam is going well, and I will see you tomorrow.